Welcome, pre-algebra class, to another episode of Mr. Chow Time. Today we're working on computing with scientific notation. This is lesson 5 on page 161, if you're following along in the book. All right. So, as you remember, when you're multiplying or dividing with scientific notation, you can use the product of powers rule and the quotient of powers rule, or properties. Actually, not rules, they're properties. And they are just saying that if you multiply two exponents with the same base, then the powers are just added, right? So this is a to the x minus y, and this is a to the x minus y. So the exponent here is added and the exponent here is subtracted. So let's take a look at an example. So scientists estimate that there are over 3.5 times 10 to the 6th ants per acre in the Amazon rainforest. An acre is a measurement of area of land, just like a square meter or a square foot or a ping, which is what we use in our houses, right? Like my house is 45 ping. What else do we use? We use square kilometers. So that's what an acre is. It's a measurement of area. And in 1 acre, there are 3.5 times 10 to the 6th ants. So if the Amazon rainforest covers approximately 1 billion acres, then what is the total number of ants? That's what it's asking us to find. And so to find that, we would multiply these two together, right? Because if in 1 acre, there's this many, how many are in 1 billion acres? Well, 3.5 times 10 to the 6th times 1 billion. And 1 billion is 1 with 9 zeros, just like that. And 1 billion can be rewritten as 1 times 10 to the 9th, right? And so with the associative and commutative properties of multiplication, we know that we can move these numbers around and we can change the way that they're grouped, right? Because all we're doing here is multiplying. So we can rewrite this as 3.5 times 1 times 10 to the 6th times 10 to the 9th. And 3.5 times 1 is just 3.5. And then 10 to the 6th times 10 to the 9th is 10 to the 6th plus 9, which is 15. 10 to the 15. So there's 3.5 times 10 to the 15th ants in the Amazon. And this is an approximation, right? This is, we're saying about. Okay. Your turn. Welcome back. Okay, so 4.62 times 8.15 is 37.653 times 10 to the 5 plus 9 is 14. But we don't want to leave this number like this because, remember, in scientific notation, we want the decimal to always be 1 after the first digit. So we need to divide this number by 10, which means we need to multiply this number by 10, right? We need to move this over 1, and then we need to add 1 to this. So this is going to be 3.7653 times 10 to the 15. Here, we have one number written in scientific notation, but the other is not. So first we need to turn this into scientific notation. This is 1, 2, 3, 4 places, right? So that's a 4. and then we can divide. 6.4 divided by 1.2 is, we're not dividing, we're multiplying, is 7.86 times, and then negative 5 plus 4 is negative 1. Okay, let's move on. Dividing with scientific notation. Dividing is a little bit similar. We just take the numbers and we divide them, and then we subtract the 8 and the 3. So 7.56 divided by 3.15 is 2.4. And then 10 to the 8 minus 10 to the 8 minus the 3 is 5. In this case, this would be just over 1, right? So we don't need to write that. This is just 2.4 times 10 to the negative, to the 10 to the 5th. Your turn. Okay, welcome back. Here we have 4.6 times 1.4. Let me do that by calculator. Calculator, save me. 4.6 times 1.4 is 6.44 times 10 to the 5 plus negative 9 is negative 4. Then we have 2.5627 divided by 5.23, and that gives us 0.49. And then we have negative 9 minus negative 3, so that's negative 9 plus 3, and that gives us, what's 9 minus 3? That's 6, so negative 6. But again, we don't want to leave this decimal here. We want it to be after the first digit, so we want to move it over here. So that's going to be 4.9 times 10 to the negative 7. Okay. So here's a real life example. In 2010, the population of China was about 1.3 times 10 to the 9th people. According to census data, the population of the U.S. was 308,745,538. About how many times greater was the population of China than the population of the U.S. in 2010? This kind of a problem is a little bit tricky for some people because they're not sure what operation to use. So I'm just going to go over that really quickly. So the population of the US is smaller than the population of China. And it's asking how many times the US population is the Chinese population. That's what this is saying. How many times does the US population have to be higher to be the population of China? So that would be like if I had 3 books and you had 15 books. How many more times the books do you have than me? Well, that's division. Which number goes on top and which number goes on bottom? Well, you can think about it like this. The population of the US times the number of times greater equals the population of China. And if we divide by the population of US on both sides, then we get the number of times equals the population of China over the population of the US. So that's what we're going to do. We're going to take the population of China, 1.3 times 10 to the 9th, and we're going to put that over the population of the US. The population of the US is this number here, right? But they're also asking us to estimate. Well, not really estimate, to round. This about how many times, this is asking you for a number that is not exact. So instead of going with this number, we're just going to use the number 3 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8. And 1.3 divided by 3 is 0.46 repeating, I believe. But again, we don't need to be that exact. So we're just going to use 0.4. It's about 0.4 times 10 to the 1. 9 minus 8 is 1. But remember, we don't want the first digit to be a 0, so we're going to move this over 1. And that's going to be about 4 times 10 to the 0. And remember, 10 to the 0 is just 1, so this is just the number 4. About 4. 4 times as great. The population of China is about 4 times as great as the US in 2010. Okay. Your turn. Until 2008, the world's largest working cattle ranch was located in Australia. A cattle ranch is just a place where they raise cows. It was about 6 times 10 to the 6th acres. And remember, acres is just a measuring word for the area of a piece of land. The largest ranch in the US is 825,000 acres. Here we go again. About and how many times. Larger was a ranch in Australia than the largest ranch in the US. So again, we're going to put the ranch in Australia on top and the ranch in the US on the bottom. So 6 times 10 to the 6th over the US, which is 1, 2, 3, 4, 5. 8.25 times 10 to the 5th. 6 divided by 8.25. What is that? I need a calculator, and I left my cell phone outside. 8.25. Oops, no, it was 6. 6 divided by 8.25 is... Can you guys see that? 0.72 repeating. And so we're just going to say about 0.7 times 10 to the 1. So again, we are going to move this one decimal place over. So that's about 7 times. Remember, this turns into 10 to the 0, which is 1. So about 7 times as large. Okay. Adding and subtracting with scientific notation. So just like with regular adding and subtracting, if you had 1.23 and you wanted to add 0.4, you could not just add 1.23 and 0.4 like this, right? You have to line up the place values. And one way of doing that is just line up the decimals, right? So this is actually 1.23 plus 0.4, like this. With scientific notation, you have to do the same thing. You have to line up the place values. And the place values is represented by the exponent, right? So the exponent must have the same value in order to add or subtract. So let me just show you what that looks like. Here we have some number times 10 to the 3rd, adding another number times 10 to the 4th. So we want to make these both the same. So let's make this one 10 to the 4th. I hate how this does that. Can't you just not do that? 10 to the 4th. And in order to make this number bigger, this number has to be smaller, right? So we're going to move this decimal point over here. So it's 0.545 plus 3.12 times 10 to the 4th. So now we can add these. 3.12 plus 0.545. That's 5663 times 10 to the 4th. Now you could have also converted both of them to 10 to the 3rd, and you would have gotten what would you have gotten? You would have gotten 36.65 times 10 to the third. And then you would have had to convert at that point. And either way is fine. Both ways would have gotten to the same answer. Okay. Let's take a look at another example. This time with subtraction. And with a number written in standard form. If a number is written in standard form, you have to first convert it to scientific notation. So this would be 1, 2, 3, 4, 5. We want to convert it to also be to the fifth, right? So 0.465 times 10 to the fifth. And we're going to subtract that from 2.78 times 10 to the fifth. So 2.78 minus 0.465, 5, 7, 1, 3, 2. All right. 2.315 times 10 to the fifth. Okie dokie, your turn. Welcome back. Okay, so the first one is subtraction. I guess we will convert them both to 10 to the 11th. All right, so I'm going to move. This number got bigger, so this number needs to get smaller so that they stay the same. So it's going to move over 2, right? So that's 0.054. 2.84 as a 4 minus 0.054. So this is 6. That's an 8. This is 7, 2. 2.786 times 10 to the 11th. Here we need to convert this to scientific notation. So this would be 86.4 times 10 to the negative 4. Yeah. Plus 5.67 times 10 to the negative 4. So it's 92.07 times 10 to the negative 4. So we'll change that to 9.207 times 10 to the negative 3. All right. And that's the end of it. Let me know if you have any questions in class. Thank you. Have a good day.